In the previous video we learned about for loops, which execute a piece of code for a specific collection of values of an index variable. For example, they might do something for each value of a variable I between 1 and 10, or each value of a variable I that comes from a particular list. But what if we don't know in advance how many times a particular piece of code needs to be run? For example, we want to run it over and over again until some condition is met, but we don't know how many steps that might take. In Python you can solve this problem using a while loop. So here is how to write a Python while loop. In the first line you write the word while and then a condition. The condition must have a Boolean value, so true or false. We met Boolean values a few videos back. Then you type a colon, and then the code which you'd like to be repeated until that condition is met has to be indented by 4 spaces as usual. So when Python encounters a while loop, here's what it does. First of all, it checks if the condition is true or false. If the condition is false, it ignores all the indented code and just continues with whatever comes after the while loop. If the condition is true, it executes the indented code and then goes back to step 1 and checks again whether the condition is true or false. So it keeps going over and over again until the condition becomes false. After that, it continues with whatever comes after the while loop. Let's look at the simplest possible example of a while loop. So in this code cell we begin on line 1 by defining a variable I to have the value 0. On line 2 we enter a while loop, and the condition is that I is less than 4. The body of the while loop is lines 3 and 4, so what they do is to print I and then increase the value of I by 1. And then finally on line 5, out of the while loop, once the while loop is finished, it'll continue to line 5 and print the word done. So if we imagine Python executing this, initially it will create a variable I with the value 0. Then on line 2 it enters the while loop, checks the condition, finds that 0 is less than 4, the condition is true, so it executes the body of the while loop, which prints out the current value of I, which is 0, and then increases I by 1. And then it goes back and repeats this. So it'll check whether 1 is less than 4, and so on. And finally, when the condition becomes false, which is when I is equal to 4, then it will not execute the body and instead continue with whatever comes after the while loop, which in our case is line 5, which prints out the value done. So what we expect to see when we execute this is the values 0, 1, 2, and 3, but not the value 4, because the value 4 makes the condition false. Let's check, and you can see that is what happens. Before we go on, let's notice something a little bit strange about line 4 of this short program. As an equation, as a mathematical equation, line 4 makes no sense. There are no numbers I which satisfy I is equal to I plus 1. But in Python, the equal sign doesn't form mathematical equations. As we've seen, if you want to test equality in Python, you have to use a double equal sign. A single equal sign in Python is simply an assignment. It assigns the value on the right to the name on the left. So in this case, the name I gets assigned to the value which is 1 bigger than whatever I used to be. So when I equals 0, running line 4 will redefine I to be 0 plus 1. And when I equals 1, running line 4 will redefine I to be 1 plus 1, which is 2. So this is a way of making I take the values 0, 1, 2, 3, and so on successively. So of course it would have been very easy to do this with a for loop. Let's move on and look at an example where it will be harder to do with a for loop. That example is about an iterative or recursive sequence, which is defined by the value of x1 is equal to 1, and the value of xn plus 1 is xn plus 2 divided by xn over 2. It happens to be the case that this converges to root 2. But it's not at all obvious how many terms of the sequence you need before your sequence is within a specified distance of the square root of 2. So let's write a while loop which will continue finding terms of this sequence until we first find a term whose square is within a particular distance from 2. But the usual way we measure distances is by using the absolute value function. And we don't yet know how to do that in Python. So we're going to begin just by looking at how to do that. Absolute values in Python can be computed with the function abs, A-B-S. So in this code cell we have abs of -1. That is the absolute value of -1, which you normally in mathematics would express with those straight line symbols. And so the answer should be the absolute value of -1 is 1. There, you can see that it is. On the other hand, the absolute value of 1 is again 1. So now we're ready to write our while loop. We'll use the variable x to represent the terms in our sequence, and we're just going to redefine it at each step of the while loop to the next term in the sequence. So we should begin with the value of x being 1. Next, we're going to enter our while loop. So we now need to think what the condition is going to be in the while loop. We need to keep going until the value of the square of the term of our sequence, -2, in absolute value is less than whatever particular tolerance we choose, 0.00000001. So the condition which should cause it to repeat is that the absolute value of x squared -2 is greater than or equal to, let's say greater than 0.123, however many zeros you like. So that means Python will keep going till it finds the first term of the sequence whose square is within 0.000001 of 2. Then what we'd like to do inside the while loop is simply replace x with the next value in the sequence. So we do this with an assignment. We'll redefine x to be equal to the old value of x plus 2 divided by the old value of x, all divided by 2. And that's all I want to happen in the while loop. Then at the end, we'll just print out the value of x. So in a code cell, the value of the statement on the last line of the code cell will be printed out. So if I just put an x there, then it will be printed out only once when the while loop has finished. So let's run this to see what happens. You can see what happens is the final value of x is printed, and this really is fairly close to the square root of 2. So while loops are more powerful than for loops in the sense that they can execute an arbitrary number of times. The problem with this great power is that it's easy to make mistakes, which can lead to your while loops which never ever stop. For example, take another look at the very first while loop we tried. We started off by setting I equal to 0. We then had a while loop where the condition was that I was less than 4. And inside the while loop we printed the current value of I and then increased the value of I by 1. Then finally, once the while loop exited, we printed the word done. But what would happen if I forgot to put the line which increased I equals I plus 1 in? Well, think about it for a moment. Pause the video maybe. Of course, what happens is that the while loop will run forever because the value of I never changes if I miss out that line. It will stay as 0 forever. So on line 1, I will take the value 0. On line 2, Python checks the condition 0 is less than 4. That's true, so it runs the body of the while loop, which prints out the current value of I, which is 0. The while loop then ends, so we go back to line 2 and check the condition again. I is still 0. 0 is still less than 4. That's true, so it executes the body again. Prints out the value 0 again. Checks the condition. It's true. Prints out the value 0 again, and so on forever. So of course this is an example where it's quite obvious what's going to happen, but it can happen by accident that you write a while loop that does this, that never ever terminates. So you need to know how you can stop Python if it accidentally gets stuck in an infinite loop like this, a loop which never terminates. So I'll demonstrate what happens when I run this, and you can see first of all that a whole load of zeros have appeared and in fact are still appearing off the bottom of the screen, and secondly this is a visual clue here, this star, which means that the code cell is still executing, and in fact it will keep executing forever because we know this while loop will never stop. So if you see this star and you can see your cell is executing and doesn't look like it's ever going to stop, you need a way to stop this, because now if you try and run another cell it won't work because Python will just be waiting for this one to terminate. So what you need to do if you are in this situation or you suspect you're in this situation is to stop Python from running, which you can do using this stop button up here. So you see if I hover over it, it says interrupt the kernel, which just means stop the particular thing that Python is working on at the moment. So when I click that, it says interrupting kernel up here and then disappears. Now you can see that we've got a number here instead of a star, which means that this cell has finished executing. So it just got terminated when I hit the stop button, and there are a bunch of error messages down here just telling you that it was interrupted by me pressing the stop button. So if this ever happens to you, whether by accident or on purpose, you can kill a Python program which seems to be stuck in an infinite loop by using the black square at the top of the Jupyter Notebook.